Let's talk about how we can combine what we know about special line segments with what we know about proofwriting. This lesson will do just that. All right, let's go ahead and jump in. In example 1, we are given that segment CE is a median of the large triangle. We're told that angle D is congruent to angle F, and that angle DEC is congruent to angle FEC. So as always, I'm going to go ahead and begin by marking this information in my picture. So I'm going to start with the first given that says segment CE is a median of that triangle. And this is where you really have to be good and you have to know what your vocab means. Median, remember, connects a midpoint to a vertex. So in other words, if segment CE is a median, that must mean that point E is a midpoint. And if point E is a midpoint, we know then that segments DE and EF have to be congruent. Angle D is congruent to angle F, and the other given we're told is that angle DEC is congruent to angle FEC. So when I look at this picture, as far as proving the triangle is congruent, I'm seeing angle side angle, where the first pair of angles are the given angles D and F. The second pair of angles are the given angles DEC and FEC. And the pair of sides are those that are formed by the midpoint, sides DE and EF. So there's kind of my plan, there's my outline. Those are the things I know I need to talk about in my proof. I'm going to go ahead and I'm going to put the angles in there first because I think they're a little bit easier. I know that angle D is congruent to angle F, and then angle DEC is congruent to angle FEC for the same reason. And that's because we're told that they're congruent. So now that's done, that's done. And now I knew these segments were congruent to one another because I knew that E was the midpoint of segment DF. And the reason that I knew that E was the midpoint was because of this whole median situation. So I need to start with CE, segment CE being a median. I know that's a true statement because it's given to me to be a true statement. And if segment CE is a median, median, remember, connects a midpoint to a vertex. So that tells me that E has to be a midpoint. And how do I know that? Well, the definition of median connects a midpoint to a vertex. And now if E is a midpoint, I can deduce that segments DE and EF are congruent to one another. That's an oldie but a goodie. The midpoint makes two congruent segments. So at this point, I've written about everything I need to write about in order to make those two triangles congruent. There's my pair of sides. There's my first pair of angles, my second pair of angles. If I pull these three pieces together, I can go ahead and conclude that triangle CDE has to be congruent to triangle CFE. My reason here from my outline, angle side angle. So that's a nice example right there of how you would use or write about a median in your proof. Let's go ahead and take a look at example 2. This one is a little bit different. In this one, segment AC is an altitude. So again, it's important that we understand the vocabulary and that we speak the language because it's very hard to write about an altitude in a proof if you really don't know what an altitude is or does. Remember that an altitude will always make right angles. So in other words, if segment AC is an altitude, then those right angles are going to be formed along segment BD. I know that segments BC and DC are congruent. And that then is the end of my given information, but I also recall that I can use reflexive property to prove that segment AC is congruent to itself. So if I'm thinking about an outline now for proving these triangles congruent, I like side angle side, where my first pair of sides are BC and CD. My angles, I'm going to call them 1 and 2. And my second pair of sides are through that reflexive property, segments AC congruent to itself. So this is going to be a side angle side proof. And I think just for giggles or something different, I might write this as a 2-column proof. If you want to write yours as a flow proof, go for it. Either the 2-column or the flow proof are both examples of formal proof, and either one is a great way to write this proof. All right, so I'm going to go ahead and write about segments BC and CD being congruent. I'm going to write that as segment DC because that's what I was given. I know that's a true statement because it was given to me to be a true statement. I now want to write about angles 1 and 2 being congruent. That's not a given. I got that by using the altitude, so I'm going to write about segment AC being the altitude. And because segment AC is an altitude, I know altitudes form right angles, so that tells me that angles 1 and 2 are right angles. And I'm just going to say here, altitudes form right angles. And I'm going to cite statement 2 because statement 2 was where I had the altitudes. And if those two fellows are both right angles, I know they have to be congruent to one another because all right angles are congruent. And now I'm going to cite statement 3 because statement 3 was the statement where I had the right angles. So the first piece is done, the second piece is done. The last thing that I have to do before I can say that these triangles are congruent is to use the reflexive property. And at this point, I'm pretty sure I have this all in here. There's a pair of congruent sides. There's a pair of congruent angles, a second pair of congruent sides. I'm all set up perfectly now to say that triangle CDE is congruent to triangle CFE. And the reason is side angle side, using statements 1, 4, and 5. Beautiful. So there's some nice insight into how you can use your new vocabulary together with your old proofwriting skills to write some new and involved proofs. All right, why don't you go ahead and for class the next time we meet, do the check your understanding question on the next page, and we'll be good to go.